we're going to talk about our third form of the linear equation, and that is standard form. Just a quick review of the other two. Most of you know that that's slope-intercept form, and in this case, m is the slope, and the point 0, b is that line intercept. We've also talked about the point slope form, where we have the slope and a point that it goes through. So the point x1, y sub 1 is the point that the line travels through, and m is the slope. Okay? Now, I pointed out a little bit earlier in the definition of one of those, that the definition specifically said the equation of the non-vertical line. The reason these two previous forms do not work for vertical lines is because the slope is undefined. There is no slope, therefore we cannot have an m there. For horizontal lines, it's okay because there is a slope to horizontal lines. It's actually equal to 0. But with vertical lines, there is no slope, so we cannot write the equation of a vertical line in either slope-intercept or point-slope form, which is why the standard form is necessary. Now, a couple of things about the standard form, and I'm going to change one thing about this definition. It says A, B, and C are all real numbers. Well, that allows for fractions and decimals, because fractions and decimals are also real numbers. I'm going to amend this a little bit. A, B, and C need to be integers, meaning fractions and decimals are not allowed in standard form. And A and B are not both 0. One of them could be, but they both cannot be. So the first thing we're going to look at is how to graph these that are in standard form, and it's actually quite easy when we're dealing with the intercepts, because what we've been talking about over and over again with how to find the x-intercepts and the y-intercepts. If you want to find the x-intercepts of a graph, make y 0. If you want to find the y-intercept of a graph, make x 0. So if we find the y-intercept first, and we let x be 0, well, 3 times 0 is 0. So we're left with just basically 4y is equal to 24. And we solve this for y. Y is equal to 6. So there is our y-intercept. It is the point 0, 6. And second, the x-intercept. Again, we let y be 0. Well, 4 times y is 0. 3x plus 0 is 3x. That's equal to 24. When solving that for x, we get 8. So the x-intercept is 8. And then all you do is connect those. So finding the x and the y-intercepts for those is actually not too bad. Don't forget about the domain. The domain here, left to right, is negative infinity to infinity. The range goes from bottom to top. Bottom is negative infinity. Top is positive infinity, because it will just keep on going and going and going. y-intercept by plugging 0 in for x. So we have 5 times 0, which is 0, minus 6y is negative 6y is equal to 60, which means y is negative 10. So we're down here. And for the x-intercept, we plug 0 in for y. So we're left with 5x equals 60. So x is 12, and that is the x-intercept. 12, 0. So there's the line. Domain, once again, is negative infinity to infinity. Range also negative infinity to infinity. With the third one, to find the y-intercept, once again, we plug 0 in for x. So we're left with 8y is equal to 12. So y is equal to 3 halves. Let that be right about there. And label it. Find the x-intercept. We plug 0 in for y, so we're left with 3x is equal to 12. So x is equal to 4. There's the 0.40. Domain goes from left to right, so that's negative infinity to infinity. Range, also negative infinity to infinity. And last, for D, find the y-intercept, we plug 0 in for x. So we're left with negative 2y is equal to negative 2. So the y-intercept is 1. And plugging 0 in for y, x is equal to negative 2. Domain is negative infinity to infinity. Range is also negative infinity to infinity. Okay. Finding for E. Y-intercept, we have plugging 0 in for x, 5y is equal to 20, so the y-intercept is 4. Plugging 0 in for y, we end up with the x-intercept of 10. Domain and range, once again, are both negative infinity to infinity. Now, with the last three, these are special cases of lines. And one thing to remember with these is you'll notice that in all 5 of the previous examples, the equation had both an x and a y in them, and the lines ended up crossing both the x and the y axis. This one has an x and a y, crosses both the x and the y axis. In all 4 of these examples on the previous page, all the equations have an x and a y in them, which means that that line crosses both the x and the y axis. Now, if you are missing one of the variables, that means that that line does not cross that axis. For example, in example F, the only variable I see is x. So that means that the only axis that this line crosses is the x-axis. Since there is no y, it does not cross the y-axis. So it would run parallel to the y-axis. So this is a vertical line, because the y-axis is vertical, and it would cross the x-axis at 3. Now, if you think about this just for a minute, if you pick any point on this line, it doesn't matter where it is, anywhere on this line, the x-coordinate is always 3. And that's where the equation x equals 3 comes from. You still need to label that x-intercept. So what that's going to do is change the domain or possibly the range also. Again, the domain goes from left to right. Well, the x-coordinate is only one value all along this, is 3. So you'll recall from when we first started talking about domain and range, if you have a finite set of values there, we put braces around that, not parentheses or a bracket. And then the range, again, goes from bottom to top. Bottom is negative infinity. Top is positive infinity. Now in G, the only variable we have is y. So that means that the only axis it crosses is the y-axis. It does not cross the x-axis, so therefore it is a horizontal line that would cross the y-axis at 3. Label that y-intercept. The domain for this one, left to right, is negative infinity to infinity. And the range, bottom to top, well, it's only one value. It's just 3. So we set that apart with braces. And finally, H. Since x is the only variable in the equation, it only crosses the x-axis, and it crosses at -1. Never crosses the y-axis or runs parallel to the y-axis. That x-intercept is -1, 0. Domain, once again, we only have one x value. And that is -1. Range, bottom to top. Negative infinity to infinity. In the next video, we'll talk about how to rewrite